Hey everybody, Mr. Covey here going over questions 15, 16, and 17 on your practice test. Okay, so question 15 says, which of these is the domain of the following function? Okay, so it gives us this log function. There's a couple ways to do this. I think the easiest is to know that domain is associated with the vertical asymptote of a log graph. Okay, so if you think about a log graph, you should have in your head that log graphs kind of look like this. They have vertical asymptotes and they kind of go like this. Okay, so your domain for a log graph is just vertical asymptote to infinity. You just got to figure out where the vertical asymptote is. Okay, the way I would think about this is to say, well, 3 to the x, has a horizontal asymptote at y equals 0. Why did I think about 3 to the x? Because this is log base 3. When you flip that to the log version, log base 3 of x has a horizontal asymptote, a vertical asymptote at x equals 0. Okay, so a normal log graph, a basic one without transformation, has its vertical asymptote at x equals 0. This one is transformed. There's transformations. You need to know what the +2 and the +4 do. That +2 is on the inside, so it moves it left 2. That +4 is on the outside, so it moves it up 4. When you're thinking about a vertical asymptote, a vertical line, it's infinitely long. When you move it, when you move it up and down 4, up, down, up 4, that doesn't do anything. That doesn't move it. It's just moving up and down. It's only the left 2 that actually impacts where that asymptote is. So the vertical asymptote ends up left 2 at -2. So that means the domain is going to be from -2 to infinity, because you figured out that the left edge of the graph, that vertical asymptote's at -2. Yeah. Next question here. A little bit of a weird question. Okay. It asks you to write the exponential function. Okay, so I'm already thinking something to the x that has the asymptote and points shown. Okay. Easiest thing to look at for this is the horizontal asymptote. It's up 1, 2, it's at 3. Wait a second. Normal exponential graphs have asymptotes at 0, right? They're at y equals 0. So this one has its asymptote at 3, it's moved up 3. So I already know it's moved up 3. Okay. What are the normal key points for an exponential? Well, there's 0, 1, 1 base. But that got moved up 3. So the 0, 1, for whatever exponential it is, would change into 0, 4 when it got moved up 3. All right, cool. That checks out at this point. And the 1 base would get changed into 1 base plus 3. Well, wait a second. The other point is 1, 8. So if 8 is b plus 3, then b must be 5. This is a 5 to the x plus 3 graph. You can always work backwards, okay? Pretend like you're not sure if this is the right answer. How would you graph this? Well, you'd think about 5 to the x. You'd get 0, 1, 1, 5. And then you would add 3. You'd move it up 3. And you'd get 0, 4, 1, 8. Oh, yeah, works out. Cool, so it's easy to check your answers. A little hard to figure it out, but it's easy to check it. Cool. Last one here. It says, identify the vertical asymptote of the following. This is really similar to that first question we did. You should know 3 to the x has a horizontal asymptote at 0. Log base 3 of x has a vertical asymptote at 0. And then you should be able to look at that +4 and that +1. That +4 is on the inside, so it moves it left and right, and it works opposite, so it moves it left 4. That +1 on the outside moves it up 1. If you're talking about a vertical asymptote, again, moving it up and down doesn't really change it. It's moving it left 4 that's going to change it. So the asymptote is going to be at -4. Cool. All right, that concludes this video.